Hello, everyone. Thank you for attending this talk. My name is Daniel. I work at Wolfram here in Brazil, for Brazil. And today I'm gonna show you and give some hints about how to connect Wolfram technology to other platforms and programming languages. The inspiration for this talk came from our clients. I'm used to visit startups, enterprise, big companies, and research institutes, universities, and so on. And in many cases, they make this question about how to connect Wolfram language to other systems, okay? And so this is a ranking. It's really updated for October. And then we have a list of the main technologies, the mainly programming language that have been used. And then, in fact, we connect, Wolfram technology can connect very well with most of them, okay? Python have been used for data science, for web technology to build web services. Java is mainly used in enterprise and big companies, banks and financial and telecom industry and so on, object-oriented and usually for business application. We have, for example, two languages here, JavaScript and SQL. They are very popular. SQL, of course, to connect to database, to relational databases. And recently, JavaScript in the server side with Node.js. We're gonna take a look around it. And this is mainly the technologies we have seen companies trying to integrate with Mathematica and Wolfram language. One important thing here is that most of those programming languages, they are basically numerical, okay? They can process numbers and matrices very well, but most cases they have, for example, that float point issue, okay? This float point issue happens because they represent the float point numbers with the word from the machine they are running, like a 64-bit equipment and operating system. And then it cuts the float point to fit the 64 bits, for example. And then if you check in Python or in Node, that is JavaScript, or Java, we have the same issue, basically. And then with Wolfram language, we don't have it. Wolfram language has double precision, and it's better to work with numerical computation, okay? This is the reason, for example, many researchers and the guys from physics, like from particle physics, or the guys from astronomical sciences, they have been using Mathematica because they don't need to care about how to process big numbers or very small numbers. Mathematica can do that very well for them. Another important thing is the symbolic computation. We can do stuff like that, for example, and then we can put an X here, and Mathematica understands this thing as we usually do in the math classes, okay? And then this is very powerful. The other programming languages that they don't have a symbolic kernel, they have big issues to deal with symbolic computation. And this thing of symbolic computation became really important now for artificial intelligence, for example. And then I usually talk to clients. They are many of them. They are used to work with Mathematica, but I like to highlight that you can run Mathematica on Linux, Mac, Windows, Raspberry Pi for electronics, IoT projects, and so on. And then we have it in mobile for Android and iOS. And one important way to integrate Wolfram technology in the web age we are now, is by Wolfram Cloud. We can publish APIs and write down our code in Wolfram language and have it easily published on the web at Wolfram Cloud. Those are very important platforms, the most important platforms that our clients have been working with. We can be there and work together. And so I will talk about Bash, that's the command line, about Python, Java, JavaScript, SQL, and Lua language. It's interesting because I'm using Mathematica on the desktop, and my desktop here, I have installed all those languages, okay? Those languages, they didn't come with Mathematica, and so you should to install them in the same box for you to exchange and call and be called by those programming languages. One important is the Bash. The Bash is so important that now Bash is even in Windows. It came from Unix, from Linux, and it's present in Mac, and now you have it in Windows too. It's the command line, the traditional command line that's very flexible, and they have lots of tools you can use in your project. It makes sense to call, you have cells in Mathematica to call Bash commands, because the number of commands you have in the operating system is really huge, and you can, in your project, document what you're doing. You can create a notebook and put here all the stuff you have been using from the operating system and have everything together in just one place. And then every command here, you can just run, you select here the language you're gonna use. In this case, we select shell for the Bash, and then you can call any command from the operating system you have, even commands you install that's not part of the basic operating system, but everything you have there in the command line, you can call here inside Mathematica, in Mathematica cells. But it's interesting, for example, I can run, for example, I can open a new cell here, and then I can select Bash, and I can, for example, call ls to list what we have in a folder. Okay. But we have usually in Mathematica, usually we have a commands to do that too. Okay. Oh, it's a big list. Let me delete. No, I can delete this thing here. Okay. Usually I have functions, okay, related to those files manipulation and everything we have in the operating system. And we can try, for example, to look, if I don't know exactly what I want to deal with files in the system, I can try, for example, to use this root card and put dir, and then I have a list of basically all related commands I may try. We can, for example, two very common tools, command line tools that have been used in data science or web development is wget and curl or curl, as some people say. And then you can install this thing in those commands in your operating system, and then you can call it from the notebook. Okay. In this case, wget get a CSV file available on the web. Of course, we have a command called URL download. You can do it in Wolfram Language instead of call an external program. It downloads the file, and then I can port the file and have a data set and check what and create graphics and everything we are used to do with Mathematica. We can call those functions and their parameters and see what happens. We can save this notebook and keep this documentation here. We have many commands and parameters. It's very, very rich to work with Bash. It's really rich. We have lots of stuff we can call. And then in the case of curl, it calls a URL. It's very powerful. There are lots of parameters. You can send passwords and send a JSON structure, for example, as required. And here I am calling it like in the command line, okay? But this is inside the notebook. I can save and keep it. It's really nice. When I have, for example, this, when I run this function here, curl, it goes there on the web and bring for me the response for this query here. It's getting a Bitcoin quote. And then the object that it returns, it's called this expression here, success. If we look at this with head, this is the object. Using full form, we can expect the structure, okay, from this success expression. And then they have an association internally, and then we can just separate and get just the result, like the standard output. So it's like you run the command line, it returns for you the standard output for you in the operating system. Now in a cell inside Mathematica. This is very useful. Now we have another option. In fact, we have a couple of options, okay, of different languages we can call. This works in the client side, okay, with Mathematica. It's not available at the cloud, at Wolfram Cloud. And we should to install those languages, okay? You should to install and set up in your environment, make it available for it to be able to be called from notebook interface. And then I can use this comprehension from Python, and the results I can produce graphics and use this data that come from the external call. I can use it with any function we have in Wolfram language. Here we have a more complex list comprehension. It creates a matrix, and then we can use array plots to visualize this this data. And then we can, for example, import resources. For example, these requests you should first to in the command line. For example, you can run pip install requests. That's an external from Python. Okay. You can install external Python libraries. Use this command here. You can do it inside the Wolfram notebook or in the command line. And then here we import this library requests, and then we make a call for a URL. And then at the end, the last command inside the cell, the result came to as output for the Wolfram notebook. And then we can process this thing like to load in a data set and explore and continue to do the computation we are used to do in Wolfram language. But we can do the same thing, okay? Using just our standard commands in Wolfram language, right? What's important? We need to register the version of Python we have and we wanna use it, okay? What happens is that in my Linux box, I have all those Python versions here, right? But I did the installation just for this last one that I did the register, okay? To be used inside Mathematica. And those other languages, those other Python versions here, I never installed this thing by myself. This came with dependencies from applications I have installed in my computer, okay? This word, when you go out from the Wolfram world, this thing of managing different versions and libraries and environments, virtual environments, is really complex, can be really tricky to deal with those environments in other programming languages, in Python, Java, or Node.js, or whatever language you work with. Okay, now we have a way to call Java inside a notebook too. And then here I am calling, I'm creating a new instance from the date object and calling it as a string. And here we see the result. Here is another call. This is a static function. I don't need to instantiate the object. And I send the parameter and it returns for me the Java version I'm working with. So this is a Java instruction inside a notebook. Here, another function that gets the runtime version. It's a little bit different. I can, for example, get environment variables using the system object from Java. I have here Java home and here the path for my box. And here, for example, I have a Java bean. It's a simple Java class with two variables, internal variables, getters and setters, and whatever from the standard object orientation programming. And then I specify the class here. And then I can now instantiate this class, create instances and call their objects and so on. This is a more didactical example, but in fact, if you have your application have built part of your research, you can just make calls, import those classes you built for your project, and then you can just call it as the usual Java language does, and then you can make usage of those legacy software you already have inside our notebook. Okay. Now, here we have something cool. In fact, J-Link, it's not new. It's there for a while. It's very useful to make calls from Java to Wolfram Language, okay? You should have access to Wolfram Language kernel. It can be remote, okay? Or be local in your own machine with Mathematica or Wolfram Engine for Developers installed, okay? This is an example. There are many examples in the Wolfram documentation. Just look for the directory where Mathematica installed in your box. You have this folder here. There are many code samples and documentation and references, really, really nice. And there are many different ways to call from Java for you to call Wolfram Language. It can be tricky because Wolfram Language is not typed language, and otherwise the Java is extremely typed language. And so there are many different ways for you to make calls, okay, from Java to Wolfram Language. What I like to do is I create a string, okay, with the Wolfram Language code, and I send them to be executed by the Wolfram kernel, and then it returns the result as a string, right? But as Java is a very typed language, you can go on and define what kind of response you want. What kind, if you want a float or if you want any data structures, the J-Link is flexible enough for you to make those calls. Another important thing here is that you can manage the kernel session with J-Link. You can open a session and keep it open for a while, create variables, create your functions in Wolfram Language in that session, and then you can close that session and open a new one. It's very flexible. It's very, very interesting, very fast when you call Java and the kernel and manage the Wolfram kernel. Let's see the next. JavaScript. Yes, we can process JavaScript in the notebook interface too. You should to install Node.js, go to Node.js website, you install this in your box, and then you register. So Wolfram, the notebook, they should know where the Node.js is, and you should inform which installation, because usually we have many of them, which installation you wanna use for your notebook, okay? You can have many different versions, and you should specify which one you wanna call. And then, like Java or like Bash, we just saw, or Python, we can write down the code here in JavaScript in Mathematica cells and have the result internally here and combine this with our functions from Wolfram language. Okay, what is the next? Oh, the next is the opposite. I can call from a Node.js, running Node in a box. I can call a section. I can make a calls in Wolfram language. In this example here, I am using this exec command from JavaScript from Node.js, okay, from the server side of JavaScript. Here, I just have a string again. I put here, in this case, you should install Wolfram script or have Mathematica or Wolfram Engine for developers in order for you to make calls. This call can be remote too. You install Wolfram script, but you can call and make a execution at the cloud, for example, at the Wolfram cloud. You should just set up, install Wolfram script and Node.js in the same box, okay, for you to make those calls, local or remote. It's very easy, very straightforward. The syntax is not that bad. Of course, usually the other languages, they are more variables than Wolfram language, and they are more, say, we will have more steps. Usually, we work with functional programming in Wolfram language, and our code is shorter, usually shorter, and usually more readable. Okay, let's check the next one. SQL. This is very important, very, very important. Startups and business and research. Here, I'm going to show you two examples from how to connect to SQLite. SQLite is a very tiny single user database, okay? It's used for for apps, lots of apps in our cell phones use this database, or for data science research. You should work with some data in your local machine, or the file is in your storage or something. And then you can use SQLite to explore your data with SQL. And you can do it inside Wolfram language, okay? And then you have, when you do a call, a query, SQL query in your database, we have the response there, the output in Wolfram language as a data set. This is very convenient. They came with the headers as the table names and so on. It's very interesting because companies, they have terabytes and terabytes and terabytes of data in their enterprise application, CRM, ERP, payroll, software like SAP or whatever you can imagine. There are terabytes of data. And so we can't download this thing from a local machine. And so using query, we can combine this thing of databases the traditional relational databases that are there sitting every company, and then bring this for our environment and combine with the curated data from Wolfram. And then we can do the same thing with MySQL. MySQL is more robust, basically the web, the favorite database for web application. And then we have it. We can connect. In fact, we can connect to many databases, okay? Like Oracle or other database. And then the same thing, terabytes of data. We select what we really need, and then we can combine with the curated data and the powerful graphical capabilities we have in Mathematica, and then easily create and do data science reports using data from the internet, from created data from Wolfram, and combining the company internal information. It's really rich. It's really nice. Oh, this is really cool. About notebooks and Python. Okay, we have two ways to go. The first option is that we have something called Wolfram Language for Python. We have a package we can install. It's a Wolfram client, and then you import this in the Jupyter notebook. That's very popular. It's getting really popular. It really seems our notebook from Wolfram. And then you can make calls. You create, import, install the library, import the library, and then you can make calls for Wolfram language. For a remote kernel or for a local kernel, if you don't send any parameter, it understands that you want to process everything in your own box, or you can specify Wolfram Cloud or whatever your instance from Mathematica are installed in your server. And then you can call data and queries from Wolfram Alpha and everything. Okay, and we have another option, the option 2. This is really cool. You can have Wolfram language, okay, inside the notebook, the Jupyter notebook, okay? You just type, you connect, install the components, and then you can just call, you should have Mathematica or should have Wolfram script installed in your box in order to make it happen, but you don't need to import the library itself and make calls using Python. You can create a Jupyter notebook just with Wolfram language, without other languages involved. It's really nice. And then to finish, what I can tell you is that with Wolfram script, that is there when you install Mathematica or Wolfram script itself or Wolfram Engine for developers. When you have it, it's really nice because you can make calls from basically any programming language. If you work with something that there is not a library, official library or something, you can installing Wolfram script in that box where you are running your application made in X language. You can make calls for operating systems and then you can call remotely, or you can call in your box, or you can call Wolfram language from your server. It's really nice. You can, for example, try to create scripts. This is a simple text file, okay? With this first line here specifying that your this script is written in Wolfram language. In here, just write your Wolfram language as you do in the notebook, but here you have in a text file, and then you can just make calls to that text file and execute and have your results. I have an example of this thing I'm telling you here. The Lua language is very popular in games and artificial intelligence. It's a very tiny script language, very lightweight, built for a university in Brazil, in Rio, to attend Petrobras projects. And in fact, we don't have a official integration, a library or something to call Wolfram language, right? And so they have this command here that is OS execute, and then you send a string, and it's gonna send this to operating system to make the call. And then we can easily use Wolfram script, and then here calling the code. It's like use SQL. SQL usually you do the query inside another programming language, right? This is the same thing basically. We are calling our code to we ask Wolfram script to execute our code somewhere locally or on the Wolfram cloud or whatever, and then the result came back to the host language that's calling it, and then we can do whatever you wanted in that X language. And this is an example with Lua language. And this is it. There are more. You can connect to R, to Ruby, Julia, Octave, C, C and C++. The integration from Wolfram Language is really good since the beginning. And web, that is very flexible. Nowadays, every programming language can make web calls very easily. And as a bonus, we have spreadsheets. We have this cloud connector for Excel. Is one option, and the other option now is integration in a partnership with Wolfram and Microsoft in order to make calls for data, access data from Wolfram Alpha in Excel. And so if you have the latest Excel versions in English, you probably are able to get data from Wolfram Language and make your calls. And this is it. A lot of stuff in a short presentation. Thank you very much. If you need help to integrate your application, just let us know, and we can help you to call Wolfram Language in Wolfram Technology, or to be called by Wolfram Technology. We can go very well in both directions. Thank you very much. Let me see if we have let me see if we have questions here. Just a moment. Oh, here, there are some questions. Let me see. I use mathematical Debian, Linux distro. This feature is calling Python and Bash from mathematical notebooks is excellent. Yeah, it's really cool. It's really useful. It's really useful. The clients, they get really surprised when they see that we can integrate very well this way. Okay, perhaps if you don't find shell bash, check the version, because the shell is available in the Mathematica. Perhaps to make this thing work together. Could I run bash in the remote server with Mathematica? I am not sure. I am not sure how to do that, but in Wolfram Cloud, you can't call other programming languages for now, okay? Just Wolfram Language. But when you do a connection from two different boxes with Wolfram Language, I'm pretty sure you can tunnel this thing and make a call in another language in the other box, if this is what you asked for. But I think probably we can do that. By SSH, I have already done that, okay? At Mathematica, installing a server on the web and open a SSH connection. This is not a new thing. It's available for some time. Okay, I can send you. There are some links in our documentation, official documentation in our website, where you have information about how to connect to Anaconda. I am using Anaconda in my box here. And I have lots of Python stuff installed that I did install, just Anaconda installed. Anyway, let's see here. Can all of those commands via example bash be run with external evaluate? Yes, I'm pretty sure we can run bash with external evaluate. Just check out the documentation of external evaluate, but I'm pretty sure it works. I run a command to connect to Python, but get two versions, and I say missing dependencies. Yes. This Python world is really crazy. It's really crazy. There are different libraries and versions and Python versions. It's really hard to make those things in the Python side to work well. It happens with Java. It happens with JavaScript too, with Node. Okay. We should dig in documentation and try and error until fix this thing. and then we connect, when we have everything working on place, we connect to Wolfram technology. This is easier than try to debug both at the same time. Oh yes, I showed this notebook is available. You can download this. In one of those slides, I talk about Python. You can see how to call Wolfram language from Python. Okay, and then there are examples in the library website and in this notebook too. You can download this and take a look. It's really cool. Okay, I can send you or drop me a line. This is my my email. Please drop me a line. I can send you examples and the links for the resources I showed you today. We are getting out of time here. Thank you very much for attending this talk, and I hope you succeed connecting Wolfram language everywhere you want it. Thank you very much.